All right, welcome to section 7-6, solving exponential equations. We're going to cover section 7-6 in two videos. This is the first one of those. This is the last section of the chapter, and it really brings everything we've learned about exponential functions and then logarithmic functions all together. This is kind of the why we learned all of the things we previously learned. And what we're going to try to answer today is the fundamental question: how do I solve an equation when the variable, the unknown, is part of the exponent? See, we haven't solved equations like that before, and we're going to learn two techniques today for solving those. The first of those techniques, method one we'll call it, is called equating the exponents. Now, I think that this is the easiest method when it works. Okay, this isn't always going to be your go-to method, but when you recognize this situation, these definitely solve very quickly. And let me give you an example, and this is kind of a trivial example, almost a little bit too simple. But let's say I had 3 to the x power equals 3 to the 5th power. And what you'll notice is right here, there's my unknown. It's in the exponent, right? And I don't really have any tools right now to know what x is. But what you'll notice here is that the answer may be a little more obvious than you would think. I've got 3 to the 5th, right? 3 to the 5th power right here equals 3 to the x. Well, last time I checked, the only thing x can be here is 5. Right? Because x couldn't be 2. If x was 2, I'd be saying 3 to the 2 equals 3 to the 5, and that just can't be. So when we have this situation, 3 to the x equals 3 to the 5, x must be 5. There's no other way to do that. And that's what we mean by equating the exponent. Now, again, this is a little trivial, so let's move on to something a little bit less trivial with the same idea. Let's say I had 9 to the 2x equals 27 to the x minus 1. Now, this is not nearly as obvious, but when I look at 9 and 27, I realize that 9 and 27 are both powers of 3. 9 is 3 squared. All right, so I'm going to rewrite 9. I'm not going to write 9 anymore. I'm going to write 3 squared, but I'm going to leave everything else the same. And 27 is also a power of 3. 27 is 3 cubed. So again, I'm going to leave everything else the same, but I'm going to write 27 as 3 cubed. Now, this is the hardest part about doing problems with equating the exponent, because I have to recognize, if I'm going to use this technique, that in this case, 9 and 27 are both powers of 3. I have to recognize that. If I don't recognize that, then this technique is going to be difficult to use. Now, at this point, let me simplify here. So I'm going to do a simplify step. And we're going to apply our exponent rules. So right over here, I have a power raised to a power. So I multiply the exponents, and I have 3 to the 4x. And again, I have a power to a power, so I'll multiply the exponents. What you have to notice about this one, though, is 3 times x minus 1. That's a distributive property problem, so I'm going to have to distribute, and I'm going to end up with 3 to the 3x minus 3. Okay, now I have a very, very similar situation to what I had in number 1. 3 raised to a power equals 3 raised to a power. And if 3 to a power equals 3 to a power, gosh, the powers have to be the same, because the definition of equal says these are the same. And the 3's are already the same, so the exponents must also be the same. So 4x, right, must equal 3x minus 3. The exponents have to be equal. We are equating the exponents. And this is a simple solve. Minus 3x minus 3x, x equals negative 3. Done. Okay, life is good. Equating the exponents. Now, I'll come back at the end and I'll do another example of this just to help clarify some more. But in the meantime, let me go on to method 2. Method 2 is called taking the log of both sides. This one not necessarily, can be a little bit more effort, but it's one that that is probably more likely to work for you than equating the exponents. Equating the exponents is definitely the fastest technique when it works, but if it doesn't, this is a good strategy. So let's say I have 4 to the x power equals 11, right? So I want to know what power do I raise 4 to get 11. 4 to what power is 11? And I could guess and check with this. I know that 4 to the first is 4 and 4 squared is 16, so I'm guessing the answer is going to be between 1 and 2, but I'm not exactly sure what it is. Now remember, though, that this is an exponent. And the inverse of an exponent is a log. And what I mean by that is logs and exponents undo each other. Just like add and subtract undo each other. And multiply and divide undo each other. So what I'm going to do here is I'm going to take the log of both sides. Okay, I'm going to have log and I'm going to have log. Now I'm going to leave my original equation alone for right now. 4 to the x equals 11. Except I've applied a log. And that is totally legal to do because I've done the same thing to both sides. Okay, now, so I've logged both sides. That was my first step. So 1 log both sides. Now, I'm going to use what I know about logs. And I know that with logs, this exponent can be expanded and moved down to the front. So my second move is going to be to put the exponent in front. So I will now have x log of 4 equals log of 11, like such. So now there is no more exponent. Yay, that was my problem. I wasn't sure how to get the exponent, well, out of the exponent, and now it's taken care of. Well, right now, I have x not quite by itself. I have x times the log of 4. So my final move is going to be to divide to get x alone. And what am I going to divide by? The log of 4. So log of 4 and log of 4 cancels. X equals log of 11 over log of 4. And that means that x is approximately 1.73. And I'm using my calculator to get that. But I log both sides, and that allows me to get the exponent out of the exponent. Now, let me show you another example of that. And what I'm going to do is basically we're going to do the same problem, but I'm going to show you how we can tweak our technique a little bit and save ourselves some effort. So number 2, we'll call it, but it's almost going to be the same problem. Nothing fancy. 2 to the x power equals 5. And my first move is still going to be to log both sides. But if I'm interested in saving some time, I can choose my logarithm a little more carefully. So in the previous example, I just did the common log of both sides. I just did log base 10 because that's something that I can type in on my calculator. But I noticed that this exponent has a base of 2, right? It's base 2 to the power of x. So this time, when I log both sides, I'm going to do the log base 2. Okay, and the only reason I'm picking 2 is that's the base of my exponent. So I'm still going to leave the 2 to the x. I'm still going to leave the 5. So before, I just did log base 10, and you can. You know, it doesn't matter what base you pick, but if I pick my base carefully, I can save myself some effort. Now I'm going to make the same move. I'm going to move the exponent out front. So I now have x log base 2 of 2 equals log base 2 of 5. Now, why does this save me work? Well, look right here. Log base 2 of 2. What I'm saying is 2 to what power gets me 2? And of course the answer is 1. We've talked about it before, but when you take the log of the base, here's the base, the log of the base, it's just 1. So guess what? This is just 1, so x equals log base 2 of 5. And I can just use the change of base formula to compute that on my calculator. So of course with the change of base, we know we're going to input log of 5 over log of 2, and we'll get our answer is approximately 2.32. So I save myself a little effort. I save myself doing a division problem if I pick the base carefully. Okay, I save myself if I pick the base carefully. Now, at this point, those are the two techniques. This is the content I want you to know. But I'm going to go back and I'm going to do a couple more examples that are a little more complicated just to give you an idea of what you might see in your assignment. So I think I'll keep going with the log of both sides first and then go back to the exponent. So we'll call this one number 3. Okay, so this would be an example of a challenging one. So I have 4 number e to the negative 0.3x minus 7 equals 13. Okay, and you'll notice that I do have a variable in the exponent, but I have a much more involved equation at this point. So what we want to do is we want to get the exponent alone. Okay, because I want to take the log of both sides, but I want to get the exponent alone first. So we're going to do the usual stuff. Add 7. Right, so 4e to the negative 0.3x equals 20. Also, you will notice that there is a times 4 here, so I'm going to divide by 4. And I will end up with e to the negative 0.3x equals 5. Okay, so I've got the exponent alone, right? That's what I've just done. So now I am going to take the log of both sides. Now, when I have an e in the problem, again, we just talked about the time saver of picking your base kind of carefully, choosing that. And in this case, I think a natural log would be very helpful. So I'm going to do the natural log of both sides. So still e to the negative 0.3x and still 5. Exponent rules apply. This guy comes out front. So negative 0.3x natural log e equals natural log of 5. Okay, now natural log of e, that's log base e of e, that is just 1, e to the first, so that just goes away. That is a 1. So I have negative 0.3x equals natural log of 5. And now we're just one divide away. Divide by negative 0.3, right, because that's a times problem. Divide by negative 0.3, and x will be alone, and approximately negative 5.365 when we do this problem on our calculator, like such. All right, one more example. And I want to do one more of the equating of the exponents. That's just a little bit more challenging. So let's do this guy. Let's say that 4 to the x power equals 1/2 to the x minus 3. Now keep in mind, I could take the log base 4 of both sides. That would get me the answer. But I'll tell you, when equating the exponents works, it's generally faster. One hint to know that I might be equating the exponents is I see that there's a variable on both sides. But at any rate, what I notice is that 4 and 1/2 are both powers of 2. 4 is 2 squared. 1/2, now this one's tricky, this is why I wanted to do this, is 2 to the negative 1. I'm going to leave everything else the same. So I still have 4 to the x, but I'm writing 4 as 2 squared. I still have 1/2 to the x minus 3, but I'm writing it as 2 to the negative 1 instead of 1/2. Now let me multiply my exponents, so I really have 2 to the 2x equals 2 to the negative x plus 3. Again, I am multiplying and doing a distributive property there. And now I have 2 to a power equals 2 to a power. The 2's are the same. The powers must also be the same. So 2x equals negative x plus 3. And you can solve it from there to get your answer. And that's how it works. So see me in class tomorrow if you have questions.